Alright guys, we're going to go ahead and pick up in 13.2 and 13.3 day 1 with radian measure. Radian measure is just another way of measuring an angle. It's similar to what you did in geometry when you talked about arc length. It's just another name for it. So here's your definition. Alright guys, so as I said, radian measure is just another way of measuring angles. It's the same as the arc length you learned in geometry. So I want to show you what it looks like, and then we'll talk about a formula that you learned in geometry and how it relates to what I'm going to show you here in just a second. Okay, so here I have a circle. It's drawn on a coordinate plane. This is the center of my circle. And if I draw in this angle, and I'm going to draw it in standard position, now when we talk about angle measure, we talk about this measure here. When we're talking about arc length, when you did it in geometry, you talked about how long this part of the circle inside that angle was with respect to the circumference of the entire circle. Well, really and truly, we're doing the same thing. When we talk about radian measure, it's not actually talking about this angle, it's talking about that arc that's associated with this angle. Now, in Algebra 2, they kind of use these terms degree measure and radian measure interchangeably because these are kind of special. All of the angles we're going to talk about are going to be put in a circle that has a radius equal to 1. And so, for that reason, it's going to be real easy to convert from degree measure of the angle to the radian measure, which talks about the arc length. Like I said, your book kind of uses those interchangeably. Degree measure, radian measure are all in reference to this angle and the arc that goes with it. Okay, so now, what you are going to do is use a kind of an altered version of the formula you did in geometry. In geometry, your formula had to do with the diameter and then the angle measure and using the circumference formula. Well, for our purposes, because every circle is going to have a radius of 1, it's a little bit different. So here's what we're going to do. If you're going to go from degree measure to radian measure, here's your formula. Degree times pi over 180 degrees is going to equal your radian measure. So let me show you one of those here real quick. If we do number 1, my degree measure is 120 times pi over 180 degrees. So your degrees will cancel top and bottom, and that will give me 120 pi over 180, and then you have to reduce. Okay, so 120 over 180 gives me 2 pi over 3 radians. So if you have an angle that is 120 degrees, the radian measure that goes with it is 2 pi over 3. Okay, so I think you can probably do numbers 2 and 3. I want to go ahead and talk to you now about how to convert, if you're given the radian measure, how to get back to the degree measure. So here is that formula. Radian times 180 degrees over pi equals the degree measure. Notice, whichever unit you are trying to convert to is what's on the top of this fraction. So if I'm going to radian measure, I have a pi on the top. If I'm going to degrees, I have 180 degrees on the top. But my conversion factor is the pi over 180, or flipped if I'm going 2 degrees. That doesn't change in either of these two formulas. So now, let's take a look at number 4. We'll do it together. So if I want to take my 5 pi over 6 radians and convert that to degrees, I'm going to multiply by 180 degrees over pi. So my pi on the top and the bottom will cancel. And I can multiply straight across the top, straight across the bottom, and then reduce, but I really don't want to deal with those big numbers, so I'm going to cross cancel. 6 goes into 6 one time, 6 goes into 180 30 times. And so then when I multiply across the top, 5 times 30 degrees is 150 degrees, and there's nothing left on the bottom. So there is my degree measure. Okay? And I think you can do the next two. All right, so the next ones, it actually ties into the last page. Should have put these on the same page, but it wouldn't fit. Let me see if I can zoom out a little bit. There we go. What we want to do is take each of those angles that are listed there, and we want to find a coterminal that is between 0 and 360. So if I want to take my 120 degrees and find a coterminal, I'm going to do 120 plus 360, and I get 480 degrees. Well, my other option is I want to take 120 minus 360 over, let's try that again. My brain is not quite back from spring break yet. So there we go. So 120 minus 360 is negative 240 degrees. Those are both coterminal. But it actually asked for a coterminal angle that is between 0 and 360. So neither of those is between, so it really doesn't have one that is between 0 and 360. So for that one, I'm going to put an NA next to it because it's not applicable. It won't happen. Okay? And then for negative 225, I'm going to add 360, and then I'm also going to subtract 360. And I want to choose the one that is between 0 and 360. So this is the coterminal angle they're looking for. For number 3, I had 660 degrees. I'm going to add 360, and I'm going to subtract 360. And I want the angle that is between 0 and 360. So this is the one I'm going to want. Okay, after you do quite a few of these, you will learn whether you need to add or subtract 360, and you don't have to do both. So now, for number 4, the angle they gave me is 5 pi over 6. Well, if you are going to find a coterminal for this, it should also be in radian measures. Okay, so let me copy these next 3 down, and then I'm going to zoom back in and make this a little bit bigger for you. Let's get that out of the way. All right, so how are we going to do this? I want to take this and find a coterminal that's between 0 and 360. Well, we've got a couple of options. We can convert this to degrees. Once we've got it in degrees, I can either add or subtract 360 and then take that answer and convert it back to radians. Or I can find a radian measure that is the equivalent of 360, so I can add and subtract that radian measure every time. So let me come right over here, and if I have 360 degrees and I want to know the radian equivalent, I'm going to multiply by pi over 180. That'll give me 360 pi over 180 gives me 2 pi. So 360 degrees is equal to 2 pi radians. So when I'm in radian measure, instead of adding and subtracting 360 degrees, I'm going to add and subtract 2 pi radians. So here we go. For number 4, I'm going to add 2 pi, and I'm going to make it 2 pi over 1, so they're both fractions, but I have to have a common denominator. So my common denominator will be a 6, which will make this 12 pi over 6, and I get 17 pi over 6. Now, my other option is to take the 5 pi over 6 and subtract 2 pi. Well, we already know what my common denominator is. I'm basically just going to subtract 12 pi over 6, and I get a negative 7 pi over 6. But what I need to know, because the directions said a coterminal angle between 0 and 360, which of these is between 0 and 360? Okay, and that's something we'll learn more about over the next couple of days. So you could convert these if you wanted to, or you can think about it. 0 is going to be 0 pi in radians, and 360, we just learned that it is 2 pi. So again, neither of these is between 0 and 2 pi. So this one is also an NA. It doesn't have a coterminal between 0 and 2 pi because it is between 0 and 2 pi. So let's take this one. If I add 2 pi to that, I get 5 pi, or I can take my 3 pi and subtract 2 pi, and that will give me 1 pi, or you can just say it is pi. So now, which of those answers is between 0 and 2 pi? Well, it would be this one. Okay, so now for number 6, should I add 2 pi to that or subtract 2 pi so that I get something that is between 0 and 2 pi for my answer? Well, if I take a negative and subtract, I'm going to get another negative answer. So I don't want to do that. I'm going to add 2 pi to this. My common denominator will be a 3. So 4 pi over 3 is my coterminal that is between 0 and 360. All right, so let's stop there, and then we'll pick up again in a minute talking about reference angles.